8 times 3 equals 24.
8 times 10 is 80.
8 times 6 is 48.
7 times 4 equals 28.
9 times 3 is 27.
Back up this one.
8 times 9 is 72.
Say it a bit louder.
8 times 9 equals 72. 7 times 3 equals 29.
9 times 7 equals 63.
8 times 5 equals 40. 8 times 4 equals 32.
8 times 9 equals 72.
20.
121.
8 times 5 is 40.
8 times 4 is 72.
8 times 9 equals 72.
9 times 8 is 72. 7 times 7 equals 49.
7 times 9 equals 63.
9 times 4 equals 36. 9 times 1 equals
9 times 5 equals 45.
8 times 3 equals 24.
Okay. Give them the score out of 29, please. If they didn't answer it, then obviously it's wrong.
You got one.
Give them back to the person. Did you get 29? Who got them all right? 3? That's it? Who got 1 or 2 wrong? How many?
1.
Okay. Be careful. Good job. 3 or 4 wrong? 5 or 6 wrong? How did you get? 3 or 4 wrong? You got a whole bunch circled there. If you didn't answer them, they're wrong, Buster. Who got more than 5 wrong? Gotta be quicker. Gotta get back into your multiplication facts. And I want you to say the facts, okay? Don't just write. Say it out in your head. 8 times 8, 64. 7 times 3, 21. Okay? 3 times 8, 24. Say it out just like we do fast math. Understand? Alright, clear those away. You guys ready? Just leave these face down on your tables. Put it away, please. Yep.
Hey everybody, how you doing today?
Good.
My name is Bill. Over there you see Sean, and that's Doug. And today, clearly we're going to be filming you guys. But I need you all to do me one big favor, if you really would. Try not to look directly into the camera. We don't want to pick that up. However, right now I want you to look directly into this camera. Okay? And if I can get everybody to go, "Thank you, benchmark," and just wave your hands like this, that would be awesome. But we're gonna, I see this face. I see this face. We're gonna try and get some enthusiasm behind it, because it's kind of, you know, it's kind of late in the day. I'm sure you guys are starting to get tired. Matter of fact, is anybody feeling a little jittery? Anything like that? Because what I really need you to do right now is just go. You go. I need everybody to seriously do that. It's very important. It's probably the most important step of this whole process. So could you all do that for me? Just go.
Ready? 1, 2, 3. Oh, no, that ain't working. That ain't working. You know how we do things in here. We'll do it all afternoon. You know me.
No.
We've heard great things about
Everybody.
this class.
Melissa, Yadi, ready? 1, 2, 3.
Everybody feels better now. Now, if you could all look into this camera, and when I say 3, wave and say, "Thank you, benchmark." You got it?
Yeah.
Yes.
Okay. 1, 2, 3.
Thank you, benchmark.
They were right. Your class is awesome. They were so right. All right. Thank you, guys. Y'all focus on your teacher, please.
Okay. So in front of you, you have a single piece of paper. You are going to have 3 minutes. 3 3 minutes, okay? So this is the type 2 type of questionnaire that you're going to do. Just do the best you can. Some of the questions you might not be able to answer, do the best you can. Read them carefully, use your dictionary if you need to, okay? Don't spend a great deal of time on any one question if you're not sure how to answer it. Just move on to another question and then try and go back after. So think about the test taking techniques that we've been learning over the last 4, 5, 6 months and try and employ them. If you can't do it, just take a guess. You have about a minute left. Can you guess? Maybe? No? No? Stop. Just put the pencils down. How many of you got 100? Oh. Nobody got 100? No, you got 100%. Oh. You did, right? No. Don't worry about it. You're not expected to get 100. This is a pre-test. So basically by the end of today, okay, we're going to go through a whole bunch of stuff today in class, and our objectives are on the board here. So all these objectives we will cover today, okay? So by the end of class, you will be able to identify at least 5 different types of graphs, which most of you weren't able to identify, but maybe 1 or 2, I can see some of you got 3 on there. You're also going to understand how data can be gathered and represented, okay, to show people what it is that you collected. Another objective we're going to meet today is you're going to identify important features of a graph. You're going to read and understand graphs. You're going to take and complete a second quiz, okay, after this, which will be my post-test for how well you did today and how well you listened today. Okay? So, put those away for now. We'll get back to those in a minute. So the concept today will be graphing. It's an important part of the CMT test. There will be several questions about graphing and tables and charts that will be on the CMT test. I don't want you to look at the graph or look at the chart and say, I have no idea what this is. I need you to have an understanding about what it is and how to solve the problem that they ask so that you can get what we call gimme points. Okay, because what you know will be gimme points. If you don't know it, you're going to struggle and you're going to guess. And at this point in time, I don't need you guessing, I need you understanding. Okay? So one of the things that we did yesterday, was you took data. I asked you to gather data about your favorite cereal, favorite sports teams, and stuff like that. So typically when you gather data, what did you do? What did you do?
I went around and asked my parents or family, what's your favorite sport, or any question, like asking a question.
Okay. So he went around to his mom and his dad and his friends and just asked them a question. So what did you do when you got all the answers? Did you ask questions too?
Yes.
So what did you do when you got the answer to the question?
I wrote down how many people like the what type of sports they like hockey, basketball.
So you say you wrote it down. How'd you write it down? Did you write their name? In what?
Tally marks.
In tally marks. So tally marks are a good way that we can use to tally or to tabulate responses by people when we ask a question. Because if I asked everyone a question in here and 7 people gave me the same answer, I can't write everyone's name, it'd take too long. So I'm just gonna maybe write a question and then I'll put little tally marks on there, okay? So, and I know a lot of the vocab today is gonna be difficult and challenging for you, but you've gotta pay attention, listen very carefully and watch, okay? That's gonna be a big plus for you, okay? So by the end of class, you'll definitely know what tally marks are, how to use them effectively, and how we group them so that we can easily read data. Because there are times when I look at tally marks and I have no idea. I've got to count every single one of them, and it just takes too long. Okay? So what we're going to do with that data, we're going to graph it all. We're going to put it all together. I'm going to tell you why we do it. I'm going to tell you what we can use from that data and how other people use instruments like that to instruct where they go from here and where they go tomorrow. Similar to how when you guys take a pretest and we go over the pretest and I can then assess where do I need to teach? What do I need to teach? Where do I go from day 1 to day 2 to day 3 to day 10 to day 20? Do I need to take 20 days? Do I need to just take 5 days? So all those concepts where you are lacking, that's what data does for me. It drives my instruction and I chart it out. And I can see where you were before, where you are in the middle, and where you are hopefully at the end. Okay? Who am I?
Mr. Douglas.
But you don't know that yet. Who's that? Do you know who that is? No idea? Who's that?
Albert Einstein.
Who is it?
Albert Einstein.
It is Albert Einstein. Who do you think that is?
Albert Einstein.
Albert Einstein. A young Albert Einstein. But most people don't know him in that light. Even though he was a great, great person at that age. And that's when all his brain cells started really kicking in and he kind of started to get the theories and everything else together. People didn't really recognize him for what he did then. It was when he was much older, when he was looking like that. Kind of scary looking. That people kind of took him serious. Okay? Oftentimes you guys, when are we going to do this? When are we going to do this? What is it? I'm never going to have to use this in my life. So why do we do math? What types of jobs do people have that require them to do math? Alicia?
A cashier job.
A cashier. Yeah, a cashier needs to do math. What else?
Construction.
Construction. Why does a construction worker need math? You don't know? You just guessed? What do you think?
Carpenter.
A carpenter? Why would a carpenter need math?
This is measurements.
That's right, because there's measurements. What do you think? Yeah, that's it. A cashier, a carpenter,
A person who builds houses.
person that builds houses. So that would be a construction person, right? Why would they need math?
To measure the tiles on the floor or the wall or door.
Okay, so those are each individual jobs, right? What do you think?
Bankers.
Bankers?
People that
Okay.
work at the bank.
Yeah? What do you think?
A company. A company might need it because
What company? What type of company?
but most companies need it for stock trades or
Most companies? How about all companies? Mike?
Engineers.
Engineers, yeah. What about math teachers? Do they need math?
Yeah.
What about history teachers? They don't need math, do they?
Yes.
No. They do?
Yes.
Why?
Because they have to figure out, like sometimes they have to figure out how long ago did something happen.
Yeah, that is true. How about you?
Yes.
Do you use math every day? For what? Give me an example of when you might use math.
In math class.
No, besides math class.
When you go shopping.
Oh yeah. Shopping, huh? What do you need math for in shopping?
Count how much you think the price will be.
Yeah, how about just counting how many you take off the shelf? How many you got there? 50? Put the chocolate back! Were you crazy? Mama, please! So every day. What about brushing your teeth? Do you think you use it then? How many of you get the toothbrush and go like this? Squirt the toothpaste all over? Yes or no?
What, on the toothbrush?
You put it on the toothbrush, right? You don't think you use math there? The length of the toothpaste that comes out? It can't be too long, can it? You know how it drips all over the sink, man. Right? You got it drips down your... Yeah? No? How about when you're brushing your teeth? You don't think you're using math? Angles? Do you do this?
No.
No, yeah.
That's not me.
No? What about the angle that you have to brush your teeth from? Of course it is. What about when you're eating your cereal? The spoon. The angle that you got to bring the spoon up and then bring it to an angle to put it in your mouth. Unless you're Jamadi, you just go.
No.
But then you're still using your head at an angle, right? So there's many, many different jobs that we use in order to use math. See all these jobs here? They all need math. They all need math. See all these jobs here? Look at that, even a bricklayer. A bricklayer? What he's doing is laying bricks. Needs math. Okay? Millwrights, people that cut wood. They chop down trees and they cut wood to turn it into whether it's furniture, planks, paper. All these guys here all need math. Yeah?
What's drafters?
A drafter is somebody that, like almost like a builder, but they draft and they create different, it could be a machine, it could be a tool, it could be a house. So there's all different kinds of drafting careers, but they call them drafts. It's like a rough draft of a structure that they may be building, or a tool or a toy or something, anything like that, okay? All these people here too. So there are millions of jobs, people, that people need math. So when you come into math class and you wonder why you have to do that, it's because I don't know what job you're going to take in the future. Okay? So we do many, many different jobs. Understand? So it's important. It's very important. Now, obviously, one of the things that we've got to get through today is we've got to get into grafting. You have your data, and we have to think about why would companies, as Kelvin said, why would they use math? Well, it drives their business. Okay, it drives their business. Ultimately, you're going to see if you were a company, and you guys are all going to become your own companies today. Okay, whether it be a sports company or whether it be a cereal making company. So take out your data that you've collected over the last couple of days or so. So on your sheets, you all use tally marks. And have you ever heard the word tally before? Do you know what a tally mark is? You never heard of it before? Okay. So when we use tally marks, okay, if I ask a question, in order to get somebody to in order to get all the data from everyone, I can't write names, so I do this little mark that looks like this. And that means one person. And this may mean 2 people, and 3 people, and 4 people. Okay? Now every time I get to 5, I go across like that. Do you understand? Because if I keep doing this, when I have to count them, I have to count every single one of them. Okay? But if I do this, it's quicker for me to count in fives, 5, 10, 15, 20. Okay? Than it is for me to go 1, 2, 3, 4, 5, 6. Okay? So these are called tally marks. Okay? And we group them in groups of 5. Understand? Okay. So you each have your tally marks. And you each ask a bunch of questions to your parents. Let's go to the cereals. So what were some of the cereals? What was your most popular cereal that your friends, parents, cousins, relatives, cats, dogs, mice, and gerbils liked? What was it?
Other.
Other? What did they say? Do you remember what some of the responses were?
Cinnamon Toast Crunch.
Cinnamon Toast Crunch. You like that too, huh? Okay. So, what was yours?
Cocoa Pebbles.
Cocoa Pebbles. Okay.
Other Cookie Crisp.
Cookie Crisp. Okay, yours?
Reese's Puffs.
Reese's Puff. What did they say? Do you remember? Lucky Charms? Oh yeah, I like Lucky Charms. I like the little white bits. I don't like the rest of it. I just like the white bits. Kind of like my little kid. She just takes out all the white bits, put them off to the side, and then she eats the other bit and she saves all the sugar for the last. But before she gets there, I grab a handful. She's like, where'd they all go? Because I ate them. All right, so you got your tally marks. So why do you think it'd be important for a company to gather data? You guys went out and asked all your friends and relatives about what favorite cereal. Why do you think a company might do that?
Represent.
To represent, yeah. Represent. Oh, not that represent. What?
Like, if anyone asks them, like, how much things, like, people been buying or anything from like, the stores, they'll show their boss or anything. Or, I don't know.
How many boxes of cereal do you think a company might make? A lot. Let's say you're the owner. Come up here. Come up. This is Mr. General Millingham. Okay, so he owns Millingham Cereal Company. Now, you're going to produce 1,000 boxes of cereal. Okay, just 1,000. You can have Lucky Charms and shredded wheat. How many boxes of Lucky Charms are you going to make? Of the 1,000, how many?
100?
And you get 900 shredded wheat?
No. 500?
And 500 shredded wheat?
Yeah.
Okay. Anyone do anything differently? What would you do?
I do like 700 Lucky Charms.
700, 300?
Yeah.
Anyone do something differently?
800 for Lucky Charms.
Why are you doing so many Lucky Charms?
Because it's, people that like it.
Yeah. How many of your people said they like shredded wheat? So what do you think is going to happen to the shredded wheat on the shelf?
It's gonna
What do you think is going to happen to the Lucky Charms?
It's gonna go off stock.
Where are you going to make your money?
Lucky Charms.
Exactly. So companies gather data, thank you, because it directs and drives them to what they want to produce. Okay? If I'm making Bentleys over here and they're costing $1 million each, and I might sell one a year, and I've got Mercedes over here and they cost 50,000, I'm selling 20,000 of those a year, am I going to continue making Bentleys or Mercedes?
Mercedes.
Of course I am. Because they're selling and that's where my money is. So companies want to get this data and then they want to go to their stockholders, their shareholders, the people that invest in them and say, hey, listen, this is where we're going. But they're not behind the scenes. They can say, why? They say, well, because this is where the money is. Well, what can you show us? You can't bring out a whole bookload of papers and say, look, here, here, here. So what they do is they get this data and they put it in a visually nice presentation so that they can see it clearly, they can read it clearly and understand it clearly. Okay? So one of the things that we're going to do right now is we're going to use some of the benchmark materials and we're going to go to representing and interpreting data. Okay? So this is just an online resource that we use from them, and what I like about this is that it's going to take you through everything that we're going to learn today. So all the objectives that we got on the board, you guys are going to learn today. Okay? So we're just going to listen to certain parts of. Oh, wait. Yeah, no.
Display the information in the form of bar graphs.
There you go.
Once you collect your data in a table, you can display the information in the form of a bar graph. A bar graph is a diagram that represents number values by bars of different heights. The bottom of the graph, or the x-axis, represents the columns of the data table. The left side of the graph is the y-axis, which represents the rows of the data table. Compare the bar graph with the data table. Which is easier to read? Why do you think so?
Okay, so let's just take that question.
Distance car traveled from route.
Wait, stop. So let's just take that question into consideration.
Line graphs. A line graph is a good way.
So let's just take that into consideration, okay? Think about the things, and these are some of the important things we need to know. Identification of a graph, okay? And these are common elements that have to be found in a graph, okay? And one of them, what was this across the bottom again? What they call that? The x-axis. And what do we call the one going up and down?
Y-axis.
We did call it the y-axis. And what is this, what exactly is this chart about? What is it? Is it cereals? What is it? Do you know?
This travel.
How about now? What is it now?
This is car travel from
Okay. So it must have a what?
Time.
Absolutely. Otherwise it means absolutely nothing. It could be the number of dirty underwear you have in your drawer. No, Naya. Get them out, put them in the laundry basket. It could be the number of cats you have in the basement. Okay, it could be the number of friends you have along a certain street. You don't know. So every chart, every graph must have a title. Okay? Now one of the things it didn't mention was this along here. What are these along here? I know they're numbers, but think outside the box. What are they, Mike?
Intervals?
They are called intervals. Okay? What are they called?
Intervals.
Say it again.
Intervals.
Okay, and an interval is the number that we go up along the side of a graph. And it must be consistent. So I can't go 1, 5, 12, 50, 60. Okay, they're going to be consistent. 1, 2, 3, 4, 5, 6, 7, 2, 4, 6, 8, 10, 12, 5, 10, 15, 20, 10, 20, 30, 50, 100. It's got to be consistent. And that consistency is going to be based on our data. Okay, if we've got numbers that range from 1 to 1,000, am I going to start with 1? What might I start with? I'm going to always start with 0, then what?
10.
You think 10? I'm going from 0 to 1,000.
100.
Maybe 50 or 100, exactly. So the amount of the interval is determined by the number of the highest value that I have. Okay, so that's called an interval. So we got our x-axis, and this again was the
Y-axis.
and this is the
Timeline.
the timeline, the title.
Timeline.
And these numbers along the side are
Intervals.
okay. Very important about a bar graph. Do you notice how they don't touch each other? Yes or no?
Yes.
Yes? Do you know what I mean by that? You see how there's a gap in between? And? Yes? Okay. That's very important about a bar graph. Okay? They don't touch. They don't touch. So don't blend them together all nice and looking like a castle or anything. They've got to be separated from each other. That's a bar graph. Understand? Okay. I think I paused.
Line graphs. A line graph is a good way to represent data that changes over time. Like all other graphs, a line graph should have a descriptive title. The graph itself looks like a grid of boxes.
So let's just look at a line graph now. So with a line graph, it's not a bunch of lines that are big blocks. Now it's just almost like dot to dot. Do you ever do dot to dot? You know what that is? Yeah, connect the dots. There you go. Okay, and that's what a line graph is. When we find data, we put a dot down on the chart. But what is common with the bar graph that's also common with this graph? Give me one thing. Put your hands up. What do you notice that's common with the bar graph and this graph here? One thing.
Numbers.
The what? Well, yes, they both have numbers. Kelvin.
They both talk about information about something.
Okay. And what was common in the last graph then is also common in this graph. What does it have in the bar graph that it also has here? It has a title. Yes, it does. What else does it have, Mike?
It has a Y and an X-axis.
Where's the y-axis across here, right?
No.
Oh, it's not?
No.
Oh, it goes that way?
Yes.
And this is the what again?
X-axis.
And these numbers down here are the?
Intervals.
And this was again the?
Title.
Okay. And this is a
Timeline.
line?
Graph.
Exactly. So that's the second type of graph. Okay?
Histogram. A histogram is a graph that shows how data are distributed in a set. A histogram may look like a bar graph at first, but the bottom of the graph represents a range of data, and the side of the graph represents the frequency with which the data appear in the set.
We don't use histogram. I use histograms. I use histograms when I'm collecting and gathering information about your CMT results. So I'll look and I'll say, you know what? Let me see how they did in 4th grade, in 5th grade, in 6th grade. Okay? So what I need to do is I need to make sure that you're progressing the way that you should be progressing. Okay? So when I do that, I look at last year's results and then I match them up like this. And you'll notice that unlike a bar graph, they actually do touch together. Okay? So, or you can plug it in over there if you want. Yeah. So they do match up together, but again, it's the same information. We don't use histograms too often. Okay? So just keep that in mind.
Circle graph. A circle graph is often called a pie chart. Similar to a real pie, a pie chart is divided into sections to represent parts of a whole. Circle graphs are often based on 100% or a whole.
So a circle graph, that's another type of graph that we use. Okay? And as it said, it's like a pie. Okay? So the thing with a circle graph is when you do a circle graph, it's going to look almost out of proportion, only because you've got to make sure each of the little slots in the pie are all the same, and that can be confusing sometimes. Okay? So, but when you do it actually on an Excel spreadsheet, they do it all for you. You put the data in, and they create the chart for you. Okay? So that's the circle graph. So what was the first graph we learned about?
Bar graph.
And the second one was a?
Line graph.
And this one was a?
Histogram.
And then the fourth one?
Circle graph.
And they all have a?
Time.
And they all have?
A time.
And what goes along the bottom?
X-axis.
And along the side?
Y-axis.
And the?
Intervals.
How much are these intervals here?
0.
What's this? What are the intervals?
1.
They're spaced by what?
Nine.
No, numbers.
1.
Ones. And the other one was spaced by how many?
5.
Think about it.
One.
Think. No, it wasn't ones.
5.
It was fives. It was fives. Why was it great? Why by 5 and why are these by 1s? Because the numbers are bigger, exactly. So these numbers, the largest number is 6. Would you want us to do 0, 5? You'd have a whole page and this much data, and the rest of the page would be blank. So that's why this one went up by 1s, okay? So this is a great graphic to represent that. And obviously with your circle graph or your pie graph, that's another example of how these proportions. What's the largest animal group in the ecosystem?
Elephant. Oh no.
What? Large animals, right? Insects. Okay? Insects make up how much?
86%.
I know you guys are a little bit far back there. It does 86%. What about reptiles?
1%.
So that's this little tiny blue section right here. So how many of these little blue sections make up this whole chart?
100.
Now how many of them would make up a whole chart?
10.
There'd be 10? Think about it. What percentage is reptiles?
1.
And this whole chart must represent how much?
100.
So how many of these little ones would we have in here? Say it.
100.
Exactly. So would have 100 little notches, and this would be 86 of those notches right here. Okay? So, the last chart we're going to read about, or learn about,
Scatter
is the
plot.
scatter plot.
If the data you're collecting suggests a trend, you may find that a scatter plot is the best way to display and analyze the data.
So a scatter plot is another one, and that represents trends, okay? And that could be one thing that you guys would do, but not with the small data that you have, but with larger data. And these are two different types of scatter plots. So this represents a trend here, which basically says that the warmer it gets, the more plant growth there is. This here, this is all over the place. It's scattered everywhere. So there's no real trend here, so you can't really analyze too much here. Okay, whether it doesn't make a difference whether it's hot or cold, whether the plants are growing or not, it's all over. Okay, so there are two different types of scatter plot graphs there. Okay, so
Find a bar graph in a newspaper or magazine.
I did that for you because I'm special and I always look after you. Anytime you go in the local newspaper, you can search through the Hartford Current, the East Hartford Gazette, the Journal Inquirer, anything, and turn to the weather section. So on the weather section, they've got a whole bunch of information there. What type of graph is this there? Got it? What type of graph is that? Louder. A bar graph. What about that down there, Anne? What type of graph is that? What do you think? What type of graph is it? What do you think? Take a guess. Begins with L. Can you say it? Line graph. Say it. Say it again. Good. It's a line graph. This is actually a double line graph, and you can have double bar graphs too. So in the newspaper it tells you all the weather. But what's great about it, it tells you all the weather from around the world too. So I'm always looking at the weather to see what it's like in London. See whether my brothers are having a good time or not, whether they're miserable like me in the cold. Most of the time, the weather's like 45 degrees, so I'm kind of mad. Okay? But you can also look around the country and see which places are warm as well. So now what you're going to do with your graph is you're going to create a chart. I don't care which particular chart you use, whether you use a line graph, a bar graph, whether you use a scatter plot, or whether you use a pie chart. I'm going to give you two pieces of paper. You're going to use the information that you just learned off the benchmark educational materials, and you're going to either create a graph using the grid paper, or you can use a pie chart, and I'll give you one of these too. Okay?
They didn't show a picture graph.
Now there is a pictograph. Yeah, a pictograph would be if you got small, then maybe you might use teddy bears or something like that. Now, can you hand these out, please, hon? Can you what? Yes, you absolutely can do both. And Noah, why don't you hand out those? So you're going to get two different types of papers. One circle, one square. You're going to have two of them anyway.
So we have to do it.
Square.